Hello friends, in this video I will discuss about the EDFA. As you know, EDFA is very important. It is used for amplify the signal. So we will discuss how the EDFA amplify the signal. So see this diagram, you can see this. This is our input signal and here is laser pump and it is WSC and this is erbium doped fiber. So here we are giving our input signal which is going to be amplified in future. So this is our input signal, and from here we are also giving the laser source, a stream of lasers at 9080 nm or maybe 1480 nm, and this both signal will be passed through the erbium doped fiber like this fiber, and after that in this erbium doped fiber our signal will be amplified and we will get amplified signal. So we have to understand about the laser pump and about this erbium doped fiber, what is happening inside. So let's see, we will use this one 9080 or either 1480, this nm. So this is energy level diagram how the EDFA works. Okay, before that I will tell you about the how this fiber is doped, because we have the fiber that is silica fiber, whatever we are using. See, this is the simple fiber silica, and this silica, and this is erbium plus iron, and this is germanium. These all are combined and heated at 2000 degrees Celsius. So we are getting, in this way we are getting the erbium doped fiber. This germanium we are adding to increase the reflective index of the fiber. So this is overall idea I am just giving about. So see what's happened in this erbium doped fiber. Whenever we are giving the laser light, you know the electron and there are energy level E1, E2, E3. Okay, so here the electron are at the E1 state, it is at the static states. So whenever we are giving the laser at 980, the electron are getting excited state and it will jump from E1 energy level to E3 energy level. The same thing applies here also. Whenever we are giving laser at 1480, it will not go to the E3, it will just go to the E2 energy state. Okay, so that's the difference. So I am giving the example of this on 9080. For example, when this 9080s will go to higher energy level, that is E3, after that electron will reach here and after it will go to the come to the E2 states. You know the distance between E1 and E2 is very less, and it is also called this state is called meta stable state. So here the electron can't stay for the longer period of time, it will just come back to the lower energy state, that is E2 state. This is also called non-radiative decay, because here when the electron come from E3 energy state to the E2 energy state, there is no emission of light and it is not contributing anything in the amplification. Here just energy get dissipated in the form of heat, means it is useless for us. And here in the meta stable state, the electron will be here for the longer period of time, that is 10 milliseconds. Here the electron will be for the 10 milliseconds, but when here the transition happen from E3 to E2, here just the traveling time of electron is just like 1 microsecond or less than 1 microsecond. So we don't have to bother about the E3 to E2 transition. See, now whenever we are just giving whenever we are giving laser here, it is going to the higher energy state. When from higher energy states it is coming to the lower energy state, that is E2, and here for the electron are for the longer period of time. Okay, and when this like the incoming signal, this one our weak signals is come here and collide with the electrons of the E2 energy level, here already electrons are there, and this our incoming signal will collide with this electron, and when this collide with this electron, the electron on the E2 energy level, it will come down to the lower energy state, that is E1 state, And when, as we know, when the electron come from the higher energy level to the lower energy level, it's emit photon, that is light. So here photon is so much, here the number you can say that here is photon already, and our photon is also coming from here, that is our signal. So all these things will be combined, and in this way our signal will be amplified. So I hope you understand this.